This is video 3 in thermodynamics by Lars Erik Øi, and this is about residual properties by EOS, or by an equation of state. And we start with replacing molar volume by the density, which gives P equal to Z times density RT. So then we just write the equation of state with the compressibility factor included. And then we have the residual enthalpy equal to minus T times the integral from 0 to rho. We have just replaced P with rho in an equation from last video. Then we take dz dt with rho constant, and we use the rho divided by rho plus z minus 1. This is equation 659. And similarly, we have an expression for residual entropy, and we divide by R to get it without dimensions, and we get ln z minus T times the integral from 0 to rho dz dt d rho over rho minus the integral from 0 to rho of z minus 1 d rho over rho, and this is equation 660. And what these equations show is that if we know the compressibility factor and the compressibility factor as a function of temperature, then we are able to calculate the residual enthalpy and the residual entropy. And the equation of state that I plan to use is the virial equation, which say that Z is 1 plus B times rho plus C times rho squared, which is also equal to then P over rho times RT. This is equation 340. If we insert this expression for Z, here Z is an explicit function of rho, and if we insert this into these equations, then we get HR over RT equals the temperature times V over T minus dV over dt times rho plus C over T minus 1/2 dC dt rho squared. This is equation 662. And a similar equation for the residual entropy is ln z minus T over dt plus dV dt times rho plus half of C over T plus dC dt times rho squared, which is 663. And the difference between these thermodynamic standard equations, but these are containing integrals. They are not easily to calculate numerically using the virial equation, which is explicit in rho. Then we can calculate the residual enthalpy and the residual entropy explicitly from the parameters in the virial equation, and then they are much simpler to use than these equations. So when P and T are specified, (340) is solved first. Only the density or the rho is unknown. First, we solve this equation for rho. Then 662 and 663 are solved explicitly, we can just go from right to left on that. And then the enthalpy is the ideal gas enthalpy plus the residual enthalpy, and the entropy is the ideal gas entropy plus the residual entropy. So the principle by calculating residual properties by an equation of state is to calculate the residual enthalpy and entropy from these equations. In the case of the virial equation, we can avoid these integrals and make explicit equations for calculating the residual enthalpy and the residual property when we know the rho and the parameters in the virial equation. And the calculation sequence is that first we solve the equation of state, and then we put the rho or the set into these equations, and then the last thing we do is to calculate the enthalpy and the entropy as the sum of ideal gas and residual property. So this is the end of the video 3.